the way it generates textures is it generates GLSL shaders to make those textures, and it uses a node-based approach. Each node contains a small fragment of code, of GLSL code, and so it compiles all this code and generates a shader that is the texture. Because and it's made in Godot engine, I already said that.
On Tuesday, I realized that I help people sell other people's stuff they
Name
don't
it's
really need.
about here. I don't know where the name.
This happened during
It's
lunch.
here, Rodzilla.
On Wednesday,
And what
anyone
I
who's in a
do in the
hurry
program,
can build a moving gun.
I did some small contributions, but mainly
Told people
I have created an extra library to add more 3D stuff. But the program already does 3D stuff
Thursday, I started blaming the world.
using sign distance functions.
For being disposable.
Because of the way it is made, each node can generate
Blaming people.
SDA sign distance functions,
I decided to
and
change the world.
we can compose those functions in a very interesting way because the inputs of the nodes are functions and not just a single value. That gives a lot of flexibility. So it's very flexible, but I will show now. So to install the program, we click here, download now. I will. Okay, something went wrong doing the download. Okay, no internet. Okay, no problem. I don't think I need internet, but you click download, and it will give you a zip file. You open the zip file, and then you put the files like I have here in the folder. It's just on my desktop, and then you just double click the executable file, and this is the program. And okay, so the program, I will talk about the program now, but okay. Okay, let me just change my internet. Okay. I think sorry about this interruption. Let me see if I have internet now. Not yet. Okay. Connect. Okay. Nope. Let me select Google. Nope. Something is wrong with my internet, but I don't think I need internet for this presentation. Unable to connect to this network. I will try the other one. Okay, I don't need it. Thanks. Okay. So where was I? I was showing here the program. So the program has like 200 type nodes, so you can drag a node here. Okay. This, for example, draws a. Let me just change. You can click with the right mouse button and change the type of rendering you want. This is the normal one I use, and you have these sliders like a normal node, usual stuff, and then this you can click Control W, and you click here, and now you can edit the node, and this is all GLSL code, like I said. Okay, you can change the code, create your own nodes. What I do is I create more nodes. So I have a library in my website. This is this one. Um, website, no, in my GitHub, and I don't have internet now. But here, if you press here, you will see basically a JSON file there. You have just to download the JSON file, put the JSON file wherever you like, go to Manage Libraries, Load Library, and then you just double click the JSON file. And if you do that, you will have more my nodes, the nodes that I have made, which are all these ones, about 100 nodes, more nodes to create 3D stuff. But the program already creates 3D stuff out of the box, so I will probably start there. So we can combine stuff here. Let me show what I mean. For example, we have here a circle, and this is a shape. We can blend the two. Okay. And like I said, you can even this node, most of the node, not all, but like 99% of the nodes are just codes. You can go here and edit the code. And these inputs and outputs are functions. So it's possible in this node, this blend node, to call this shape several times. So it's not a value. Okay? Because you can do this, there are many possibilities. For example, creating 3D stuff. For example, I can make here a sphere. Okay, you have some GUI for this, or box. Okay, and you have a built-in 3D viewer to show these shapes. You right click this and select ray matching material, and you can go here and click here preview 3D, and now you are seeing the sphere. It uses a technique. It's basically using for the guys who know it, it's actually running a cube, and the shader of the cube is like a window into the shader, into the ray marching shader. Okay, this is the built-in viewer. You have here also the albedo, metallic, etc. For example, I can add here a texture, for example, a pattern. Okay, change here the parameters, normal. Okay, also change the other parameters, and now I will start to use also my library. I have made, if you want to start doing something, I advise you to do this. Don't use the built-in. Install my library. Go to MEF SDF, and here you can you have a render. By the way, so if you right click here, I can start writing render, for example, and now this is my render. To show the render, you go to now to preview 3D. So this is just one node. I'll start from the beginning. This is just one node. I can drag here this, and now this already is a shader because you can have default inputs. So this is a default function, and this is another default function. Is a default function that generates the 360 image, and this is the sign distance field, the MEF sign distance field. This MEF sign distance field is it's an enhanced sign distance field because it works this way. You specify which of the it outputs not just the sign distance function, but also colors, metallic, and the other components. So if I want to override this, I have to first create an object. Okay. By the way, if we press one of the nodes, it will preview the node itself. But I only want this output, so I will control click here, and it will lock this output, so I can now click the other nodes and to continue working with it, and the output is always the same. So this is the node that generates this MEF SDF, and this node has here the sign distance function, the classic one. For example, this is a torus. For example, here, can play with this. Okay. Also I have some easy stuff to manipulate this. I can also try to change this and add again a texture, so it multiplies my color. I will just put white, and here you have you can play with the camera. So this is the shader, so I can I don't have internet, that's a problem, but trust me, you add this node, which is the debug. You click show shader, and this is a shader toy shader, so it will work just with copy paste in shader toy. You also can for example, the camera, I will now create an animation to move in a circle, move the camera in the circle pointing at 0, 0, 0. I will just use some basic math functions, the sign of time, which is $time, and I will step a bit far, multiply by 5, and as you probably know, okay, this already is moving from one place to the other. I use now the cosine. Okay, we have an animation now. Let me just slow down a bit. And just filling here with some parameters, probably a bit faster. Okay, so let me see. Okay, so you can do some simple animations with this and create shaders this way. So as I said, this program is for building textures, but as you can see, you can generate shaders using the program. I will show now what can you more complex stuff that you can do with this library. One of the things that you can do, is create, for example, another object. I just copy paste this one, and I will do now a boolean, smooth boolean. Okay, put it here, and now it has it's the default object. It's a sphere. I can override the sphere using, for example, another torus, and we now blend the two. Let me put another color, for example. Okay. I can, of course, everything. I can, for example, change this again using time. Oops. Sorry. This is better. So a sine function times 0.5 plus 0.5, no, plus, for example, like this. Not too big. Big also. Okay. Yeah, so you can play with it. Also here you have some controls here to trans rotation, position, also scale. Change here the components of the render, and it will always blend with the other shape. Okay. Another thing, you can. I will now remove the animation. 5 or 2, for example. No, that's too big. Okay. Another thing that you can do, for example, is to use. You can deform displays. I think it's displays. Displays. Oh, okay. And connect here, and we'll displace using a 3D text, not a texture, but a 3D function. Let me a function that gives a value for each point in space, a color for each point in space. Okay. Here. In here you start seeing some artifacts. You can try to correct these artifacts with this correction. This is one type of deformation. You have also other types of displaces. Displace, you have displace by direction. No, by direction it's not so useful. Display, wait. In here it will just displace somewhere. Okay. Oops. Sorry. Yeah. So here it will always displace only the surface. Okay. Again, you can add some correction here. You should put the correction should be the minimum possible. Okay. Okay. You can also add okay the color. Another very useful thing is to colorize. Let me get rid of the metallic. Mm. Okay. You have this will multiply this color with this color. So if I put, for example, black or red, the colors are not correct. So you can double click here and add, for example, between white and blue and play with this. Okay. Okay. So another feature that is now in Material Maker. By the way, before I sing, I jump into that. I will now. So let me just put the standard render. Okay. You can. I also implemented a path tracing, so you can also do a path tracing here. You just change the render node. If I connect here, nothing will show because we don't have lights. So in path tracing, we need real lights. So using. I will use this, which is basically pre-configured. Let me just. I can do it by hand, no problem. Just to add a light, just add the emission. So this will generate the standard object that is a sphere. We have to combine. I have some easy combinations like this union for that combines for objects, and then you add this path tracing here, and okay, so you'll see some flickering here. We can change the render to temporal anti-aliasing with 2.2 um, correction. See, it takes. Now we start. Okay, start to converge. I will move the light. Also also add, let me add here checkerboard. It now takes some time to compile because every time you connect something, as the shader starts to get more complex, the compile times are also bigger. Okay. So here I added a checkerboard, and this also has a light here preset up. I will delete the other light, I don't need it. This is just to show that you can make more renders, okay? If the ones that I made and they are built in are not good enough for you. Actually, mine are not that good. They don't respect the rules. the So are more done by hand with some that are not physically correct. But it looks good. Also, it takes a long time to converge. It's just a very basic path tracing. But if you give it enough time, it will generate some pretty images. Okay. You can also add. Let me just change here the render to a better one. not the render, the scene, the environment. That's the word. Yeah, here. This one. Okay, here. Okay. You can enter 360. So I have this image. You have some Material Maker has some 360 HDRI images. This is one of them. It's also cool to do some renderings. Everything works, okay? So this is not static. I can still play with this and change the colors, and everything works. The most, again, to fix the output, you press Control, and it's now locked. The bigger problem is the shader compilation, because this is always building a shader each time you connect a node. The shader times are very slow. I wish there was a quicker way, like a draft way, a very quick way to in the drivers. Like if we could say don't optimize it very well and just compile it as soon as possible, and sometime after a better shader would arrive in the drivers, but I don't think there are any APIs to do that. Okay, so this was what I wanted to show on this part of the rendering library, how it works. Now, for creating this, you typically need to use these nodes, but the Material Maker 1.0 has a very cool feature, which is called Easy SDF. Okay, so I created everything from start again. It's clean. You can just drag this node here, and you can use the built-in node for, again, you can use the built-in node for rendering. Okay, which is this one. You could change to ray marching material, and you can use this, but I will use my render. Okay, you can search my render for, if you write render, this is the render. So I show you the path tracing render. This is the standard render. This is just a combination of these two, and this is one that generates 360 images for using with VR and that kind of stuff. So this one, let me change here to extend mode. So how does it works? You double click here, and this generates two kinds of functions: a 2D sign distance function or a 3D sign distance function. Right now is in 2D mode by default. So if I create here, for example, a circle, it will generate this function. It's basically a tree where that you can edit, create, for example, shape, boolean, smooth union, and you drag here the two. Okay, so you can easily create stuff signed without using nodes. Actually, these are kind of nodes, but are in the tree view. Here you change the properties. Okay, so this has this 2D mode. Let me just delete it, and you also can create 3D SDFs. Like here, I create a sphere. Okay, and it has these helpers to change here the values. Okay, and this not only creates the sign distance functions, but also outputs. Let me just click OK. The albedo, metallic, these 4 parameters, so you can edit them all there. Okay, so I will edit again with double click, and for that you have to on each object. By the way, this is the first version, so it's the first version. It will evolve in the future, but you can already do many cool stuff with it. So you can do here, and then you can add a color. In this case, we will add albedo, and the albedo, we specify that you want the albedo, and then you specify if you want, for example, a uniform color, like for example red, or if you want a noise function, for example, okay, with usual parameters, and you can, for example, change the brightness and contrast of the function. Put here, and yeah, I can now change the brightness and contrast of this, and you can create another sphere. You see here that when I change the sphere, the texture is changing. It's fixed in space, the texture, but you can go to the albedo and click local, and if you do that, it's sorry. Oh, I understand. It's not. It was not on the right spot. Okay. It still does. You can't click. It doesn't support that. It will eventually, of course, do that. Not now. You have to know the place in the tree to move the specific object, but we will get there. Now we will blend. Let me change here the colors. Okay, to change the color, I can, for example, create here a filter, simple gradient, and for example, put it red, something like this, for example. And then we have 2 spheres, this one and this one. We can now create Boolean smooth union. Put this one here, this one here, and now you have a smooth Boolean. And it also blends every parameter. We only put albedo here, but you could put other parameters. You can also change here, of course, how much blended you want the two, and also the color has a different parameter. It has a different. You can be different for the color. Okay, so if I hit apply, and so how do you connect these ones if you only have this MEF SDF here? You have to add this object. You have to create an object in my library and put here the albedo, metallic, roughness, and emission. We don't have emission, but and now I control click here. Okay, so it's here the object. Just to show the native render. Where is the native render? I don't know where he is. It is a. Let me see if he's behind the. No, I don't know where the render was. It was supposed to be here. Let me just try. Oh, here it is. I will just copy here, paste it here. By the way, it has nothing to do what I'm. If I go to a notepad This is very cool. If I, for example, click this node, do Control C and Control V, this is the code of the node. I can select, copy, go to a different thing, environment, and the node will appear. So I can change the code here, and a new node will appear here. And also, for example, my library is only code that when you save the file, the code is included with the node. So you don't to use a saved file, you don't have to include to have my library. Okay, that's also very cool. So I was showing the default render. Okay, here it is, the default render, just to show that it also works. I have to change here to ray matching material. Bedo, metallic, roughness, emission. So it also works inside that box that I was. That's why sometimes when the view is outside the box, you can see this. Okay. By the way, these shaders can be exported to Unity and I think no, I think it's only Godot, not Unity and Unreal, only for Godot. In Godot, you can export exactly this shader that is here, create a box there, and apply this shader to that box, and you will see exactly what you are seeing here. So the object is not the box itself; it's what it's inside the box in using ray matching. Maybe you can do some nice things with that in a game engine or for a demo, for example, creating a demo with lots and lots of boxes, and then you just render the shaders in the boxes with a world. That way you can probably scale a large world with lots of different shaders. You can also use parameterizations, and with parameterizations you can create different objects, just changing some parameterizations, for example. It's an idea. So, continuing. Okay, preview 3D. My render is not that nice, but I can also PC image. Go here, environments, epic forest. Okay, gamma correction. Okay, he has a built-in procedurally made environment, but a real one is better. Okay. So continuing with EasySDF, there are many things that you can do here. We have spheres. You can also have a torus also. Okay. Scale it here. Also add color. Okay. And you have like an ellipsoid. Okay, the ellipsoid, no, ellipsoid. Can change exactly. something. You also have um, some functions. This okay. Mirror 3D. It will now exactly. So it's applying a mirror to the things that I'm doing. I don't know what I'm drawing here. Add the color, albedo. Create here uniform, like blue or something. I'm not a 3D artist, so I can't do proper stuff. Sorry. Uh, but that there are some nice things already done with it with this. More stuff. We can also, for example, in this create here filter, create a deform. Okay, generation. Now it will yes pattern. So I will try to create nope. Let's see what is wrong here. Okay. Okay. This ellipsoid is being just to make it bigger. One has to be one, for example. Now I'm going to deform this filter, deform the texture, create it's the inverse that I want exactly to make these nice marble textures. Okay. So it everything blends. Um, another thing that you can add. Let me try to delete some things. Create sphere. Okay. Add albedo. And then add a uniform. I can also deform the surface using a shape. Sorry. It's probably not here. It's here. Ah, it's here. Start. So it will distort the sphere with a texture. Okay. Purling noise. Okay. You can of course blend this. this. Scale uniform, no.
Dung, dung, dung. We kindly warn Paulo that he only has 10 more minutes of presentation. Thank you.
10 more minutes. Okay.
10 more minutes. Thank you. Dung, dung, dung.
Okay. Simple gradient. This was the one. Yeah. Create Boolean, smooth Boolean union. Okay. Apply. It's in here is the object that we created there. So you can create. I don't have time to create some interesting stuff. Just to show you the features that we have now. I'm going now to show a nice use case. In this case, I will use the 2D. I will generate a 2D sign distance function to create something. Okay. View standard. I don't think this is correct. It's okay. So I'm going to create here a box. Union, a smooth union. I'm racing against time. Okay. So again, to start, if you don't know how to start, I will say it again. Just drag this render and start, and then you have to create an object, and this is the sign distance function. You can click and drag, and it will show the things that you can connect. Okay, so here I want a box, and here I also want a box, and okay. Okay, that I will put this here, so you can use this as a helpers to place your objects. Let me change the color. Okay, this is the smooth union. Okay, the normal. You can also, of course, have subtraction and intersection. Now we want a union. So this is there are stuff that you can specify this smooth function can be a 2D distance function, can be mapped to a 2D distance function, and we can play with that. That's what we're going to do. So instead of this smooth boolean, we will use an advanced one. Advanced boolean has a lot more options. Okay. So right, this is the same. We already have more stuff to say where you want the smooth, but you have now more. You can customize where the union with this sign distance function to the field. And we can use the easy SDF for it. Okay, we'll connect it here. It will not show anything probably because. So how does it work? We have to specify. So this part is one side and this part is the other side. I will create a box. You'll understand what I mean. Or better, if I just put this and apply, and okay, I have to change here to custom. So now it's the 2D function. The intersection is that that circle that generated this. So I can double click here. Let me see. Okay, if I put it here and hit apply, yes, there is a problem here with the. But we can manage that. Create shape box. Apply it here. And another. It's not here. Okay. I don't know what is not. I don't know what is now. Why? Oh, it was here. Okay. We don't need the union. Okay, if we hit apply. Oh, it's broken for whatever reason. Okay. So we can create here a circle. Not a circle, for example. Create shape a box. To make, for example, stairs, manual stairs. I don't know, in my tests this wasn't happening. I don't know why this is happening. For whatever reason, this is not rendering correctly. Strange. Oh, okay. We can also add here, actually it's kind of simple. I can just go here, edit the code, and fix it right now by dividing the here, but I don't need that. So this is the union that we were doing here. Okay, so if you understand, if I for example put this here, okay, here, or here this box, add us another box. Yeah. Okay. And we can play with some stuff that create here a larger one of the things that we can play is the way to color the things. We can color by normal. for example. So stuff that is pointing up will have this color. Stuff that is going in this direction will have this normal. We can also mix the two colors like we were doing. We can also add a texture to fill with the mixing. Let me add some noise here. Okay. See, this is all dynamic. So if I rotate this or change this or okay, another, let me see another thing that we can do. Can, for example, Paul. This is the operator smooth polar repeat that does a smooth polar repeat, and this was created automatically. Okay. And okay, this was what I was going to show. I have another thing to show if I can, if they let me. I think it's very cool. It's a way to automatically detect edges and creates that and modify edges. Let me again drag my render. An object is always the render, the object, and the SDF. Okay. So this is a box with this radius. Okay, one thing that we can do, let me just fix the output, is because we can on each node run the subnodes as many times as we want. We can do stuff like a blur function, an SDF blur. So it's not really a blur. I don't know how to do that. If anyone knows how to do a real blur, please tell me. What I do is I just sample the SDF on the sphere many times and blur the result. So this blur, this have blurred the initial box. And what we can do with this is if we pick the original SDF and the blurred one, we know the edges. If we make the difference, we know where the edges are, and we can apply a color for this. If it's positive, we apply a texture. If it's negative, we apply another texture, and we can play with it. We can also apply a texture to do the blending between the two, so it creates some nice shapes. I will show that now. Okay, I will. This is just to show you the blur. I will now paint. I will paint. It's called paint. The nodes are called paint edges generic. Okay. She has the base STF and okay. We can also apply a small blur here, and we have the blurred one. For example, here is red, and here will be white for the modified STF. Okay. So, see, it detected the edges. I will also, this is the first. I don't. We can of course use just the radius, but it's just for showing purpose. I will do a more interesting shape instead of just this box. Let me first create here a box. Okay, this box. Let me do just a easy 2D render, a fast one to edit the shape. I don't think I can have multiple renders. I don't know why. Okay, this is a very basic render that just renders directly two shapes. I will now hide this. I will let me fix here the render, and then box. Have a smooth boolean between the two boxes.
Paulo, temos de acabar.
5 minutes.
No, you're already 5 minutes over.
Okay, just let me.
Just try turning it off and on again. I just want to make a cross. I just want. Why is life so complicated?
How much time? I'm presenting.
-5. I already told you.
Come on. Okay.
It has a twister.
Has a twister. Now I will use this here and here.
Blurred twister.
And here.
Render.
Yeah.
Ah.
And here we can texture pattern. Okay.
Oh. I like noise.
Yes. And you can, of course, twist here. It automatically. Can displays noise. Oops. Nope. I will show
Crash.
just the already done ones because I don't have time. I have to respect also the other guys who are presenting.
We can flash the light a lot if you want.
And start putting the music. So now I will just show stuff that is already done. So let Inércia, let me see, Inércia. Advanced Boolean. Okay, this is one of them. Okay. This was was the example that I done previously. Something like this. This one is the deform edges. Okay. Here is it uses a different node that scope edges here. Okay. It's instead of just the color, and of course everything just works magically, creates
and you can export directly GLSL.
You can copy paste. You can go here, debug, show shader, copy paste, and it's on shader toy. This.
Bam. Okay. Thank you very much. Everybody, please give him a round of applause.
Sorry for the time.
It was much better this time, Paulo. You were only 10 minutes over. So, much better. Yeah, you could have.
An hour and a half already. I can stay here.
Anyways, the food has arrived, so if anyone is hungry, you can help yourselves. We will take 5 minutes to set up the beer seminar, and then it's beer o'clock, as Genio was hinting. So, yeah, grab some food, run to the toilet, and we'll be right back soon. Also, the deadline for music entries is at 8, which is somehow soon, so if you haven't submitted, please submit now.
Eu não tenho net, esses gajos tiram não sei o que tens de fazer. Mas eu mostro, espera aí, deixa eu ver se eu tenho net agora. Eu vou para o YouTube. Epá, é um bocado lixo, mas tu podes passar por tu se comprima o shader e fica bastante mais compacto. Não é, mas é tio, tem
Thank you.